Recording in progress.
Yeah, cams on everyone. Let's start off. Great. It's been a month. Hope everyone is doing well. Anyways, so others do keep your cams on during the session. Great. So let me tell you how we are going to go ahead with this. Now, unlike mains, right? If you see in mains revision, we have literally taken up every simple thing, every small thing. Like there, the main purpose was coverage. We just a sec. And we needed to cover as many topics as possible. It is more about coverage. Now in advance, it is more about going in depth, trying to connect multiple chapters, trying to do 2 to 3 different concepts at the same time. Right now, the thing is, think of the sessions like this. In these sessions, we will not be able to cover each and everything. It is impossible. Like I can teach you 100 models, and advanced they'll ask you one or one model. So that is anyway there. So we can't guess or we can't do so. But the whole point is, these sessions are kind of like to initiate you. It is to stimulate you, like to give you an idea. Okay, this is the level of the things that we are doing, and this is the level of the material we need to be solving. Getting it? Because advanced preparation will never end. You can do it for another 3 years, and it still will keep going on forever and ever. Getting it? So for these sessions, when you're coming, I'll be expecting you have done your work and you're coming. If you have not gone through the notes, right? There are some of you who are maybe new. I'll give you the notes end of the session, but it is preferable because if you look at your class notes itself contains around 1200 to 1300 questions. That itself is your huge collection of questions. Getting it? Now, one thing you need to understand, advanced matlab ye nahi hai, they're going to ask you each and everything out of the world. If your cams are not on, you'll be removed from the classroom. So yeah. And then later on, don't cry. Right? So again, understand this thing. Advanced does not mean they'll ask you everything impossible questions. Even if the advanced paper comes tough, right? Let's assume the paper comes really tough. The only difference would be this. They will always maintain, at least 20 to 30% easy questions. So generally the order is this. If a paper comes moderate, you will find around 30% easy questions. You will find around 50% moderate questions. And maybe you'll find 20% tough questions or difficult ones. So if you see there is an 80% there, which is actually based on standard models, and maybe little they will twist it, they'll not directly ask you the questions. But if you have done your work, you have done some high level problems, you will be able to handle easy and you'll be able to handle most of the moderate. Paper becomes really tough. This might become 20%, this might become 40%, and this might become 40%. So it's never going to happen like, the whole paper is something mind-boggling out of the world paper. Advanced paper, they're not trying to, skill you guys. And anyway, no one is asking to score 100%. So why this is important? Because I have seen some of you, right? You are obsessed with the tough questions when your standard models and your regular work is not done properly. Right? So keep that in mind. Getting it? So we will talk more about it at the end of the session. So we'll start it off. So today we'll be doing off with electrostatics, Gauss law, and gravitation. Right? Like I said again, I'll be giving you questions. You guys will try to solve. I'll give you some time and then I will explain you in detail. So that is how we will go through it. I'll not be teaching you concepts directly. I'll be giving you a question and I'll try to teach you concepts from there. Right? So let's start it off. And end of the session again, we have a, we'll not call it speed test. It is your multiple choice questions. Just like we did for mains, different speed tests and all. Here we will be doing testing. That is important. So anyway, so let's go ahead with the first question. Let's start off with something moderate. So we have an hexagon here. Plus Q, plus Q, plus Q, plus Q, plus Q, and plus Q. There are 6 charges exactly from the center. We have a charge here, plus Q and mass M at a height Y. Again, don't worry about writing the question. Focus on solving. You'll get the PDF anyways. So, and remember, gravity is also present. So this charge is out of the plane. The side of the hexagon is A. First question, find Y for stable equilibrium. Everyone knows equilibrium, but what is stable equilibrium? Find force as function of y. A and B are both are related. Find time period for small oscillations. Let's take it for y greater than 0. This is for a given y. Let's get this. Electrostatics, stable equilibrium comes in which chapter? Work per energy. Oscillations come in SHM. 3 chapters. Again, don't worry about solving and getting the final answer. As long as you got the equations, it is sufficient. That much I understand you can solve. Solving part is something which you can handle. So we will focus more on understanding the concept, getting the equations. As long as you can frame the equations, your job's done. You got something, you can type in the answer here in the chat box to the co-host. I hope the question was clear. Anyone didn't understand the question, please ask, because I'm not writing the whole question. So there's a charge Q at the center above the plane of the hexagon. Someone is not clear the question, please don't hesitate. You can just always unmute and ask. Get the force part, from there you'll get the A part. Let's see the force part. You can keep doing. If you got the force part, you keep going ahead. I am just doing only the force part. It is just basic Coulomb's law. So at a height y, if you look at any one charge, this is how the force is going to be. This is how the force will be. Getting it? So that is due to one of them. So now if you calculate it, let this angle be theta. This angle will be theta, right? And this distance will be small r, and this distance will be a, and this is a right angle triangle, and that height is y. So r is equal to root over a square plus y square. That is the distance between plus q and small q. And the force ka value F will be k q small q by r square, which is a square plus y square. Now, similarly, if you see there are 6 forces acting in all directions, only the vertical components will add up. So the force on small q charge will be 6 times F cos theta. Right? So that would be 6k by a square plus y square. But what is cos theta? Adjacent side by hypotenuse. That is y by r again. That will be a square plus y square whole power 3 by 2. That's your force. This is the force acting on the charge. This is the Coulomb's force. Don't forget there's also an mg acting. So if I put F is equal to mg, right, that would give you the, what do you call, the equilibrium position. Now, if you actually try to plot this graph of a force, you will notice something. So how do you find the equilibrium here? Pi much greater than A, that is not the condition, right? You're like asking what is the condition and you're saying y is much greater, y is infinity. So let's try to plot the graph. Can you do this thing? At what point is the force maximum? Get that. That is pure max. Force is given. Find the position where the force is maximum. That shouldn't take much of our time. Find the position where the force is maximum. So you can actually find stable equilibrium two ways, either with the force or with the energy also. Yeah, you'll get it at a by root 2. So for maximum force, if you do df by dy equal to 0, you know how to differentiate that, right? So you will end up with y is equal to r by root 2. How do I know that without even differentiating? If you guys remember the result of a ring, isme yaad hai? You get the maximum force at r by root 2 and minus r by root 2. And for a ring, the field formula is also the same, kqx by r square plus x square whole power 3 by 2. If you see, the function looks exactly same. This is what I was saying. You should remember things. Exam, if you'll go and try to derive each and everything, you'll run out of time. You should know your standard results. You should be able to connect stuff. Any doubt so far? So if you try to plot the graph of force versus y graph, this is what you will notice. When y is 0, the force is 0. The force will increase till r by root 2. And after that, the force will decrease and tend to 0 at infinity. This is the force profile. So as you go away from the center, the force will repulsion due to will increase. And after that, the force will keep on decreasing. So what? So how do we get an equilibrium from here? Stable or unstable? Let's try to think of it like this. So when you're balancing mg, let's say mg is somewhere here. So how many solutions are there? There are two possibilities, isn't it? There is an extreme possibility where you're at maximum. But if you take a general conditions, there are two positions where you can be in equilibrium. Do you guys agree with this? That means you can balance mg at two different positions, right, on that vertical line. All clear with that? So for a given mass, there are two positions where you can be in equilibrium except r by root 2. Now, because of that, what happens? Let's see the conditions. This is a good one, right? This question, right? I gave an hexagon, but I can even ask you with a ring. I can ask you with two current wires, so you can play around. But the idea is the same. So try to understand the meaning of this. So when you're taking this, so there are two positions. This is your position 1. This is your position 2. This position is where your force is maximum. So that means there is a point above the maximum force point and there is a point below the maximum force point. You can balance the weight at both these positions. So this is r by root 2. Everyone clear with me so far? Now let's assume both the positions and see. There is a mathematical way of doing it, but let me show you the force method also. First, let's assume you are keeping the point at 1. Let's say if particle is at 2, okay? Okay. Now you're at point 2. If I push the particle down, if particle is at 2, and let's say it is pushed down, can you tell me what will be the forces on the body? There is a repulsion force and there is an mg. Now if I push down, what happens to f? Decreases. Agreed? If it is pushed down, f decreases. And what about mg? Mg remains constant. Then which way will the body go? F decreases, therefore it goes down. Now you tell me, if I push down and if you go down, what kind of equilibrium is this? Unstable, right? I hope everyone knows what is stable and unstable equilibrium. In unstable equilibrium, it is like a hill, or if you push it down, it just goes away, it does not come back. It goes down. So this is unstable equilibrium. Clear with this? I push it down, repulsion decreases, mg is still more, I will come down, so you're gone. Similarly, if I push it up, right, again F decreases. No, wait, I did a mistake. If you push down, F increases, I'm sorry, because you're going towards the maximum. So F increases, it goes up. So this is actually stable. Remember, if you go down, force will increase. So in this graph, this was 0.2. So if you push it force, you're going towards the maximum point. So you will actually come back. This is your stable equilibrium. What if the particle is at 1? Now it will happen the other way, what I said. If particle is at 1, same story, F and mg. You push it up or push it down. If you push it up, F increases. It goes up. So this is unstable equilibrium. So what is the answer for this? So for stable equilibrium, y ka value must be greater than equal to r by root 2. Clear with this? Or like you're saying, y ka value must be between infinity and r by root 2. Should I take r by root 2 also? No, r by root 2 ka inequality. Clear with this? Is that making sense, everyone? So there are 2 points where you can keep the particle at rest, but both are not stable equilibrium. Only if the particle is above the F max, then it will oscillate. If you keep the particle below here, you can keep it at rest, but you need a small disturbance and this thing goes off. Clear? Now, there is another way to do this. You can actually find the energy of the system, which is U is equal to potential energy minus K Q by a square plus y square root 6 times plus potential energy mgy. And then you can do maximum minima. Du by dy is 0. And d square u by dy square must be greater than 0 for stable equilibrium. U is minimum. That also works. That is a mathematical way of doing it. Clear with this? Then for time period, what we will do? We displace it by small x. So assuming y is greater than r by root 2. So let the particle be displaced by x. So now the new force acting on the system will be k q by 6 times a square plus y plus x whole square whole power 3 by 2 minus mg is equal to mass into acceleration. So 6k you can take out that y common there. You'll end up with a square plus y square. And this will be 1 plus x by y whole power 3 by 2. You can actually do the binomial approximation there. And if you remember this whole term, there is a whole power 3 by 2, right? So this is square and whole power 3 by 2. You can replace that 6k q this thing with mg. There, basically this term you can replace with mg here. Clear with that? And since x is much more smaller than y, you can use binomial approximation. You will get a proportional to something constant into x. I will leave the working to you there. Again, for small oscillation. So you're taking that initial y to be constant. All clear with the steps? So same question, they'll ask you like this. You have a ring here of charge q and radius r. There is a particle of mass m at rest. Find the height where it is in stable equilibrium. Same story you'll get. It should be greater than r by root 2. Same question I can ask you this way. I'll get a plus q charge and put a minus q charge. In this case, it will be reverse. Less than r by 2 will be the stable equilibrium because it's attractive force. Clear with the steps? All clear with this? This ending part is fine, right? That you can handle now. Let's see the next one. We have a charged particle here. plus q. This is fixed. We have a particle plus q and mass m projected with speed u. Both are positive charge, so they will repel. This is at a distance of b. This distance b is also called as impact parameter. If you remember, we did this thing in Rutherford scattering model in modern physics. Again, after the session gets over, definitely take a rough paper and try to do them again on your own. Getting it? It is important. When you do them again on your own, you'll realize, okay, this is what I was thinking that time. This is what I was doing. It is important. Getting it? Because if you don't do the revision again, then it won't help you. If you just think like I'll remember and go to the exam, it won't work. So no, because of repulsion, what will happen? This will go like this and it will deviate. And this actually forms a hyperbola. You can neglect any gravity. So when it goes away to infinity here, so if you look at this particle, this angle here is your angle of deviation. So if you remember what is angle of deviation, angle between initial and the final. And somewhere here you'll get a minimum distance, r minimum. The r minimum is an easy one. Find r minimum and angle of deviation. R minimum would be a mains level question. And find the angle of deviation. Same question I can ask you in gravitation. In that, the particle will get attracted and go like this, isn't it? So there, in that case, theta will be like this. So story is the same. So a charged particle is projected towards another fixed charged particle. Both are positive, so it gets repelled and goes off in that hyperbolic path. Initially, it is very far. Find the minimum distance between the two particles and find the angle of deviation of the projected particle. So this thing, right, was actually Rutherford alpha scattering experiment. Hope the question was clear. Anything question you didn't understand, please ask. Because I'm not writing the whole question to save time and I'm just putting it verbally. So anything that you're not clear with the question, please ask. And keep trying. It's fine, completely fine if you don't get anything. If there are 5 steps, figure out 2 to 3 steps. Great. And don't worry about simplifying and getting the answer. If you can just frame the equations, you're done. And by chance, if someone has finished and you're just waiting, then don't wait. In the Zoom, right, I sent you some extra questions. You can download them and do them in case you're done with what I'm giving you and you want to do more. Or else you can do it after the class also. I'll send that in the group anyways. But first, do the questions in the class notes, what I'm giving you. No, because if someone is finishing it off, why to waste their time? They can do the extra questions. Get the minimum distance. That was easy. And this is something I keep telling you in the class if you remember. If you're not going in a circle or if you're not going in a straight line, there is only one way to do. Energy conservation, angular momentum conservation. R minimum was easy. I know you should have done that. Why bol raha hu? Standard models, right? The moment the question is given, standard model should not take more than a minute or so. So then you can save time. Then you can go and attack the other ones. So how do you find the minimum distance? This is state one. This is state two. When the distance is minimum, the velocity must be perpendicular to the line joining the centers. Why? Because if there is a velocity along the towards the center, then this distance is not minimum, right? So the component of velocity along the towards the center must be zero. State one, state two, energy conservation, half mu square. Let the velocity be v, half mv square. Then the potential energy is k q by r minimum. Initially, it is zero because it is very far. This is your energy equation. Conservation of angular momentum, you will take torque about the center is zero. Why? Because the force is always, the repulsion force is always passing through the center. So torque about the center is zero. Therefore, angular momentum about the center is conserved. So be careful with that. Don't blindly say angular momentum. Just say that word. Angular momentum about center is conserved because torque about center is zero. Initial angular momentum, MUB. Be careful. Angular momentum is MR perpendicular V. I don't care how far you are. What I'm interested is only the perpendicular distance. And this is MVR minimum. There, you're done. Two equations, two unknowns. Solve them. You'll get R minimum. You can even find V also. I hope that was clear. That was a easier one. How do you find the deviation? Hi, Ishil.
So, how can we use the energy equation here? Because, for example, if the charge wasn't fixed,
Yeah,
it
figure
was
it out. Figure
movable.
it out. Figure it out. Figure it out. That you shouldn't be asking. That was a silly question. You still not can't figure it out. After the class, let's discuss. But I hope others figured out, right? Why we can conserve energy. Still, someone is not able to figure it out. I'll tell you. But wait, first you think. You have still time, right? Then what about the second part? Think before the second part. I tell you if you can figure out, great, or else I'll tell you after the second part. Okay? But trust me, you can conserve energy. Think. What about the second part? No, no, please ask your doubts, huh? But I want you to think a bit before I tell you something. If you're in 11th standard, I would have told you directly by now. You're not in 11th. What he is, Aish? Let him figure it out. Exam mein you and I won't be there to tell him. How to do the second part? Now listen, second part is little here. It is little difficult. If you have not seen that before, it is little difficult to figure it out. So let's see. Now one thing is clear. Eventually, when you go to infinity again, what will be your speed? Again, when you reach infinity, your speed will become again u. Do you agree? And if you look at this line, this distance will again become b. Why? Because when you go to infinity, your initial speed and final speed will be same because potential energy is zero. And angular momentum has to be conserved. So MUB must be equal to again MUB. So finally, when you go to infinity, the thing will become something like this again, right? Great. So initially you're coming like this and you're going like this, right? So if I want to do the change in momentum, so this is your U final, this is your U initial. So change in velocity will be U final minus U initial, which is U and U. So that means your change in velocity vector is in this direction, delta V, right? And this is your deviation delta. So if this is delta, this angle will be 90 minus delta by 2. This angle will be 90 minus delta by 2. Therefore, the change in momentum of the particle for the entire motion will be 2 times mass into, how much is that? M into delta V. But what is delta V? You can take that two vectors ka component, u cos 90 minus delta 2. So that will be 2u sine delta by 2. I hope everyone is there with me so far. So the delta is the thing which we are trying to find. So this is my change in momentum of the particle, which is 2 mu sine delta by 2. Any doubts on this? Right? Simple vector subtraction. So basically, this is u final and this is minus u initial. दोनों vector का resultant लिया done. Great. But I know from Newton's second law, change in momentum is nothing but force into time. Now, again, what force is this exactly? This is the force acting on. Yeah, right, Ishil, you understood. But you understood, no, Ishil, why work done was zero? That was clear, no? Yeah. Good. So now the problem is when you say integral f dt, now tell me one thing. You are taking change in momentum in which direction? Let me show it on the next page. Now listen carefully. That's what I'm saying. Try to grab things one after another. So this is your change in momentum ka direction. Agreed? That means when you say integral f dt, this f bar also must be force along delta p bar. Agreed? Force in that direction into time should give you change in momentum in that direction. Make sense? So when the particle is somewhere here, any random time, this will be the force F. Let this angle be some theta. Getting it? And let this distance be r. So this is the force at any random distance, which is k q q by r square. So this formula becomes 2mu sine delta by 2 will be integral f cos theta. This is the force along that direction dt. This will be f is again k q q by r square cos theta dt. Now look at this thing. I don't know r, it is changing. I don't know theta, it is changing. I don't know time. So there are three variables on the right side integral. But there is something else here. Now if you look at the angular momentum here, which is m r v perpendicular, this can be written as m r v perpendicular is nothing but r omega. Make sense? So this can be written as mr square omega, which is nothing but d theta by dt there. That means dt by r square is nothing but d theta by ml. And luckily, if you remember, L is always constant, which you can calculate, right? So L is nothing but MUB. So take this guy and dump it here. So you end up with K, Q, Q. That's anyway constant. I'll push it outside. dt by r square is d theta by m into L into cos theta. Did you see something? We converted everything into theta. That becomes K, Q, Q by ml integral cos theta d theta. Perfect. And what are theta ka limits? Remember, you're taking theta from the center. And if you remember here, these angles are, this angle was 90 minus delta by 2, and this angle was 90 minus delta by 2. So your limits here will go from minus of 90 minus delta by 2 to 90 minus delta by 2. Now if I integrate this, 2mu sine delta by 2. So there we brought circular motion, we brought angular momentum, we have everything there. This guy would be k q q by ml. Cos theta ka integral will be sine theta. Limits will go from minus 90 to delta by 2. 90 minus delta by 2. Dump it there. You can substitute that angular momentum also. K q q by ml, and this would be how much? 2 cos delta by 2. Bring it here, you got tan delta by 2. And everything else is constant. You know how to calculate that. K q q by m square ul. There, that's your delta, everyone, deviation. There. Please have a look at the steps. So again, let me just explain the whole thing again. Cos theta of the force at a finite point. So again, what did I do? Listen to this thing. I know initial momentum is mu, I cap. Final momentum is mu in this particular direction. So the change in momentum for the entire motion is 2mu sine delta by 2. I hope that was clear. Now you're taking the change in momentum for the entire motion, and the entire motion is going to take infinite time. How much time? I don't know that. Clear? But we know from Newton's second law, change in momentum is force into time. Integral f dt. But which force exactly? You could have taken the total force, but I can do even better. Instead of saying total force, I will take the force of the particle at any instant acting in this direction, which is f cos phi for the whole time. So if you actually integrate with time, the limits will go from 0 to infinity, isn't it? If you can actually find f as a function of time, the limits would have gone from 0 to infinity. So that I'm integrating for the whole infinity. Clear? Now the problem became, I don't know r square, I don't know theta, I don't know tt. Right? Now the idea here is this. End of the day, you want to find theta. That means you have to keep theta here. Somehow you have to convert dt in r square into theta. The only thing which is constant here is angular momentum. In angular momentum, you can get an omega. From there, you can get d theta by dt. So that is the idea there. Maybe you have a d theta there. And luckily, we got dt by r square is d theta by ml. Once we kept it there, we are done. Puruja, clear with that? Got the steps. Angular momentum, Newton's second law, right? A bit of a circular motion there, but yeah. Definitely try to do this thing again on your own. You might not get the exact same thing. You might get a variation of this. That's what I'm saying. Exam they'll do like this. They will say there is a planet of mass m. A comet is coming with speed u. The comet comes and takes a turn like this. Find the deviation. Ho gaya na? Same, exact same question tha. Instead of electrostatic repulsion, it became a gravitation question. You're getting it? The same question they can ask you like this also. Let's say we have a particle charge q, mass m. There's another particle charge q, mass m. Both are projected with speed u. Both are free to move. Now what will happen? Because there is no external force on the system, central mass will remain at rest. So this particle will go like this particle will go like this, isn't it? Now they can ask you find the deviation. Now what will you do? You will stand on the central mass and do the problem, isn't it? Because the central mass, the force will always pass through central mass, no matter how it goes. So that's what I'm saying. Don't think like this will be the question. They might ask you a part of it. They might ask you a variation of it. So in this, what I want you to learn is this one is an important technique that somehow I converted that r square and dt into a theta term. That was something new. If you don't figure out that, then you couldn't have solved it. Clear with this? Any doubts on this? Please ask me.
Sir, could you please explain the f cos theta reason once more?
You're changing momentum in this direction, right? So can this force ever change the momentum in the perpendicular direction? So if you're changing momentum in a particular direction, then the force must be along the same direction. So at any random point, if the force F is like this, only F cos theta is responsible for changing momentum. Fair enough?
Yes.
So change in momentum in a particular direction is force in that direction into time. Integral. Clear? Let's see one more. No, we can't write V is equal to R omega. This is V perpendicular, isn't it? V perpendicular can be written as R omega. V tangential, na? V perpendicular matlab. That is one more thing. Look at this. The velocity is in this direction. So this can be divided into two components. This is your V tangential or V perpendicular, which is V perpendicular. That can be written as V is equal to R omega, isn't it? Speed of the particle is not R omega. V tangential is R omega. Clear? That is one more thing. Be careful because I wrote it V R omega. V perpendicular here. V is not R omega. V perpendicular is R omega. We have a cube here. This thing is sigma, 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 sigma. So all sides have uniform charge distribution, sigma. Find the force on one face due to the other five faces. Side A. So we have a hollow cube, surface charge density and not volume density. So since all are positive, they will repel each other. So there is a force between them. Find the force on one face of the plate due to the other 5 faces. In case you don't know this concept, you should go back to Gauss law. I'll do one thing. Wait. I'll refer the notes. You can at least go there and check it out. That's important. The idea was this. This one. If you remember, the force on a plate is equal to sigma into flux due to the charge on the sheet, page 24. But if you know, great. Go ahead. I'll give you a minute. Forgot the concept? Let me help you with one. There are 2 parts in this thing. First thing, you should know this concept. In case you don't know, I'll just brief it up. Listen carefully. If you have any random sheet, and let's say we have a point charge q, so we are basically manipulating the Gauss law to give you the force. Now this charge here, if you take any random chota piece here, the electric field will be this way. The area vector will be this way for that small piece, and this angle is theta. Agreed? So the flux on that sheet will be integral E bar dot dA, that's your flux ka thing, which is E dA cos phi, cos theta. Agreed? Now, the force on this small sheet, if you look at dFy, the force on that small sheet, which is nothing but charge on that small sheet, dq, right, into E cos theta, because you want only the vertical component. Clear with this? So, you can clearly see here, I don't know the electric field, I don't know the area, I don't know the cos theta. Getting it? But your E cos theta here, I'll just put an integral only. If I just multiply q here and dq here, we will get that only. See, let me do it from here. So integrate on both sides, you will get Fy is equal to integral E dq cos theta. But what is dq? dq is nothing but sigma into area, that is the charge on that small sheet, into cos theta. This is the charge on dA. Sigma is constant for the sheet, so we get integral E dA cos theta. E dA cos theta is nothing but E bar dot dA, which is nothing but flux. This is the result. So the force on the sheet in the vertical direction is surface charge density, sigma, into, this is the flux passing through the sheet due to the point charge. Or due to the charge, basically, flux passing through the sheet, that's it. Is this concept clear, everyone? This thing you should know. If you don't know this, you can't go ahead with the question. So based on this, there were other type of questions. A simpler question was this, which we did in the class notes. There was a square plate charge was, this was sigma, and exactly at the center, here there is a charge plus q at a distance of a by 2. The side of the square plate is a. The question was this: find the force between the square plate and the point charge. Now, you know how to find the flux for this thing, no? That's a standard question, remember? So flux in that sheet due to the point charge will be how much? Construct 6 more faces. Total flux is q by epsilon. You'll get 1/6 of the flux. That is q by 6 epsilon. So what will be the force? Sigma into q by 6 epsilon. Bas. Is the idea clear, everyone? So if somehow you know how to find the flux, just multiply sigma and you'll get the force. So in this question, I know the formula for force, but I need to find the flux now. So can you find the flux on one face due to the remaining 5 faces? So the question has become a flux question basically. So if you don't know how to find flux, you can't find the force. Take a minute. How will you find the flux for that? I hope this was clear, but in more detail, I wrote it in page 24 Gauss law. I just told you in little fast. So sigma square by 2 epsilon. Okay, project did get something. Let's see. I don't remember the answer. Let's see. So when I take the cube, this is what I will think. See, consider a Gaussian surface very close to the cube. Okay, consider a Gaussian surface just almost the same side. You're almost touching the cube. What is the total flux? Flux total will be the total charge, which is sigma into area is a square into 6 times by epsilon. Agreed? That is the total flux passing through the whole cube. This is the flux passing through the total cube. By symmetry, you can argue because all the 6 sides are identical, the total flux passing through one face is 1/6 of it, which is sigma a square by epsilon. Agreed? Now, let's take that just one face. If you just take this one face, and if you go very close to the face, what is the electric field very close to the face? If you go very close to the face, it will look like an infinite sheet. Very close to the face, it behaves like infinite sheet. What is the electric field due to an infinite sheet? Sigma by 2 epsilon. Now remember, this total flux, right? This is due to all 6 faces. But remember, what do I want? I don't want due to all 6 faces. I want the flux due to the remaining 5 faces on your plate. Are you getting it? What you got here is the flux due to everyone. But when you calculate the force, that flux must be the flux due to the remaining people on you. You should not include your own flux. So if E is sigma by 2 epsilon, then flux due to this plate is how much? Sigma by 2 epsilon into a square. So on the total flux, this plate is contributing sigma by 2 epsilon a square, and the total flux is sigma square by a epsilon. Therefore, flux on one face due to the remaining 5 will be the total flux, which is flux total minus flux due to that due to the phase. I'll just write this as phase. Subtract them. You will end up with sigma a square by 2 epsilon. What is the force? Sigma into the flux due to this thing. Sigma a square by 2 epsilon. Sigma square a square by 2 epsilon. Clear with this? You can do that. Or you could argue like this also, consider a Gaussian surface almost touching the face on both the sides. What's the total charge enclosed? Sigma a by epsilon, isn't it? Half will go that side, half will go that side. You can argue like that also. Clear with this? So this is one important thing, that concept, like calculating flux is one thing and finding force is one thing. Any doubt so far? I hope everyone understood how we calculated the flux. Same thing, you can ask one more question on this. I don't remember, maybe I asked you this in mains revision also. But anyways, let me ask you, it's a good one. We got a cube here. This was sigma, and that was sigma. The other three faces, minus sigma, and minus sigma. C is the center. Find the electric field at the center. You can take side A. Daniel, you can do that. वो sigma by 2 epsilon करना बोल रहे हो? Yeah, you can do that.
So the flux due to the other four faces will be zero only, because it's
किसमें?
These four faces, the vertical faces, and
we don't know Nare, how the field lines are going. How do you know the field lines how they are going? See, you can't take इसका field यहाँ पे sigma by 2 epsilon नहीं है. That is very far, right? You can't use that infinite sheet ka formula. Only because you're very close, you can do that assumption. What you said was also fine. You can take two cubes and you can assume the total flux is that. Isn't this electrostatic pressure into area of the one? But otherwise, you can't use electrostatic pressure, right? Electrostatic pressure is sigma square by 2 epsilon for what? For spherical shapes or for conductors. This is not a conductor. Right, Advait? If it is a conductor, then the electrostatic pressure is sigma squared epsilon. And circles are special. If you take spheres, they have a uniform distribution, then it is sigma squared by 2 epsilon. But if you take any random shape, you can't say sigma squared by 2 epsilon.
It was for a sphere. I just thought it looks.
Yeah. क्या करना था? Anyone remembers for this? How to do? Let me show you this. Let's go the other way. Don't try to find the field and all. You can't do from there. Taking a square plate and finding a field, it is messed up. Integration is hopeless. You can't do that. Let's go this way. Just now I taught you this. If you take one square plate, assume there is a charge q at the center. Okay? It is at the center. This is sigma. So what is the force between them? The force between them is charge sigma into the flux, which is q by 6 epsilon. Agreed? Now, can I also argue by Newton's third law, this is the force on the charge q due to the plate. So can I say this is nothing but charge q into the electric field due to the plate at the center? Are you sure? QQ will cancel. That means the electric field due to one plate is sigma by 6 epsilon. Sure. Now that is due to one plate. Now how many are there? There are 3 positives and 3 negatives. So the force on the charge q will be sigma by 3 epsilon, because there is 1 plus and 1 minus, I cap, sigma by 3 epsilon j cap, sigma by 3 epsilon k cap. Is that making sense? Because this plus and this minus will push in one direction. This plus and this will push in one direction. This and this will push in one direction. Sure, opposite faces have sigma and minus sigma. So you'll get double of it. If that looks confusing, I'll write this thing. I'll write it as 6 epsilon and I'll say into 2. So basically I get sigma by 3 epsilon root 3. This will be sigma by root 3 epsilon. This will be an integer equation. That is the electric field at the center of a cube, where you have 3 plus sigmas and 3 minus sigmas. Clear with this? Yeah, cube is not very close to the center. So when did I say it is close? This is the thing which I used record. Nah, I didn't take cube to the center. All sure with this? You'll get used to it. This is what I was saying. You should be able to connect stuff. Let's see, little something else. So we have a planet here, mass m and radius r. And we have a rod here of mass m and radius r, same length, right? And this is rotating around the planet. This is called a space elevator. If you remember, we have done this kind of thing in the notes. So this is one of the project by NASA actually. Now, when you're sending rockets into the space, the biggest cost is the fuel. So somehow, if I can actually connect a rope kind of thing here, like a spaceship, right? And if I can make it rotate in such a way, right, the centrifugal force will balance the attraction force of the gravity. That way, this rod will always remain radial. So this rod is rotating in such a way, no matter what you do, the rod is always radial like this. Clear? So this is called a space elevator. So this is a rod of mass small m and radius r. It is just above the surface. So a rod mass m and r rotates around the planet, floating just above the surface. So the idea here is, if I can build a space station on top of this, I can send, all the rocket car parts and materials through a train or something through the rod, and then we can assemble them here, and then we can launch from here. So yeah, that way it will save you a lot of fuel, right? And if you want to conquer planets, you want to conquer space, you need to create space stations like this. They're on the planet floating just above the surface. This could be a good paragraph. First question, find omega for this to possible. If you rotate too fast, you'll fly away. You rotate too slow, you'll crash onto the earth. Plot tension in the rod versus X graph. How does the tension in the rod vary with X? And I hope you remember, free ends always have zero tension. If there's someone who's primarily focusing on mains only, right, and I think these sessions will go above the head. So you take a call on that, whether you want to attend or not. because these things, it'll be like this only, it'll be all little much higher level. We'll try to combine as many different things as possible and as weird questions as possible. That looks right, Regina. Get me the tension. Get me the tension as function of x, where x is the distance from the center. You can do that way. But anyways, do attend few classes and then you take a call about that. If you're doing mains, then yeah, to you. Because for mains, we already done the revision. You can go through that material. That's really useful. We have done more than 400, 450 questions in that and mains ka revision material. Everyone must have got omega by now. So how do we do that? And again, people who got mains make good score in physics now, please be, don't underestimate physics. Mains ka physics was bullshit. Getting it? That is nothing like advance. Just because, I have seen this happening. There was 2 years back, there was a kid who scored 100 out of 100 in mains. वो बहुत ओवर कॉन्फिडेंट हो गया था लाइक हाँ मेरा फिजिक्स सब आता है सब आता है बॉस एडवांस का फिजिक्स इज नॉट एट ऑल लाइक दैट इट्स अ मॉन्स्टर but max ka mains of max for mains and advanced, right, they're pretty close. Getting it? You will find them, they'll be pretty close. But in a good way or a bad way, physics ka mains, right, is scoring, but please don't become overconfident. That is the level, mains physics mein mujhe aa gaya 90 marks 80 marks, so I think advanced bhi ho jayega. You will get slaughtered. The kind of preparation you need to do is something else. So think of what we are doing today. ये questions tha matlab this is what you should get comfortable with. You still have time, 2 months time to figure it out. That's what I'm saying. Day one, it might be overwhelming, but after a month, you will think this is normal. And that will happen only when you do the work. So make sure to do whatever I'm teaching you, revise them, right? And I already sent you the GRSC ka sheets. I'll forward them again today. Start doing that. So simple thing, attend the sessions, right? Solve a material, get your doubts cleared, write papers and resolve them. That's it. Only 3 things you have to do. Attend the session, solve a material. Material I told you already, GRC and FITG, that's what we're going to solve, right? And for new people, I'll send you today. And you have to write papers. Anyway, so let's see how to do this thing. So from the center, I'll take a distance x. We'll take a small piece here, dx. Now, if you just want to find omega, your life is easy. The net centrifugal force must be equal to the net attraction force. Or net gravity. So what is the net centrifugal force? Integral dm omega square x. Limits will go from r to 2r because the length of the rod is also 2r. Gravitational force is g m, small m is dm by x square, limits from r to 2r. What is dm? Dm is total mass of the rod is small m by total length of the rod is r, length is dx. Substitute there. That would be m omega square by r integral x dx. R to 2r, and this will be g m by r integral dx by x square. This would be m omega square by r, and that is 2r, 3r square by 2. This would be g mm by r into 1 by 2r. That 2r goes off, one small m also goes off. You end up with m is equal to root over gm by 3r cube. That's your omega. So if you rotate with this omega, you're not going to fall down. You will go radially. Clear with this? Second part of the question, how do you find the tension? Now, you want to find the tension that as a rod, you always have to take a small piece, cut it off. In case you want an idea about that, the first time we encountered that was in circular motion. Do you guys remember this question? A rod is rotating with omega, find the tension in the rod as function of x. And what did we do here? Look at this, what we did. We said at a distance x, take a small dx. Then there, this was your free body diagram. So this was page 58, circular motion. I'll leave it there. You can refer that. So definitely go back and refer. Huh? That helps. Because this is the thing. So then if you draw the FBD of that small piece, I'm exaggerating it here. What are the forces? Tension T plus dt. Remember, mathematically, we always assume the functions are increasing. So we'll assume T is always increasing. This is T. The centrifugal force dm omega square x. The gravitational force gm dm by x square. There. So from here you will get dt is equal to gm dm by x square minus dm omega square x. Now remember this, the free ends, because there is no one touching you there, the tension will be always zero. Because if there is a tension there, who are you pulling exactly? If I cut it here and if there is a tension, whom are you pulling exactly? So you cannot have tension on the free ends. So when you integrate this, the limits dt, this guy is gm m by r dx by x square minus m omega square by r x dx. You can take the limits. If you take from 0 to t, now be careful here, limits will go from r to x. So here is also tension 0. This is also free end. So when tension is 0, x is equal to r. Or you can take 2r to x, both will work. This is your function, everyone. Integrate this, you will end up with something. I will leave it to you. And when you solve this, you can actually even find something more interesting. Without doing anything here, can you tell me at which point tension is maximum? Because you're going to draw a graph, you need to find which point tension is maximum. There is answer is here only. Can someone tell me where is the tension maximum? You wrote it right, Aditya. For maximum tension, what should be that? dt by dx is 0. For max tension, dt by dx is 0. You already have a dt from here, na? So gm by x square minus omega square x is equal to 0. You'll get x is equal to root over gm by omega cube, omega square. And what is omega square? Gm by 3r cube. You'll end up with root 3r. So the rod ka maximum tension occurs at root 3r. It's not in the middle of the rod. And if you try to plot this graph, tension versus x graph, the graph will start at x is equal to r. It would increase and then decrease, something like this, because the free ends have zero tension, and this is root 3r. That's not a parabola. I didn't know how to draw, so I'm just drawing it. It's not a parabola. It increases and decreases, and the maximum value occurs at root 3r. If this is a more than one choice question, I'll ask you omega. I'll ask you the point of maximum tension, right? And I'll also ask you center of gravity. So that is the new one. Find the center of gravity of the rod. Now, center of gravity is technically not there in the portion. So what they'll do, they will give you a small paragraph and they'll expect you to solve. So what is center of gravity? So again, this discussion we did have in center of mass. I know I told you to revise gravitation and everything, but yeah, welcome to physics. You have everything everywhere. I'll brief it up anyways. We discussed it somewhere here. I think we did it in gravitation, I guess. Okay, I'll explain anyways. What is center of gravity? First of all, what is center of mass? That was easy. Center of mass was a point where it's a geometric, what do you call the center of the geometric object or whatever. So RCOM was the integral RdM by integral dm. This was the thing. So what is center of gravity? Center of gravity is a point about which the net force acts on the system. Now, for uniform gravity, if your gravity is uniform, center of mass and center of gravity are same. COM and COG are same. So if you take a tall building, let's say 1,000-kilometer building or a 1,000-kilometer rod, when you have gravity here, now if you look at here, the lower floors of the building will experience more force compared to the upper floors on the building. So because of this, the center of mass will act at the center, but the center of gravity will be slightly below. Are you getting it? Because there is more force at the bottom floors, the force must be more force at the bottom compared to this. So what is the formula for center of gravity? So the position vector of center of gravity is given by integral r into df by integral df. This is the formula you have to use. Meaning, just look at this. If the force is uniform everywhere, df will become dm into g. This will become dm into g. Gg will cancel. This will become center of mass formula. Is that making sense? So whenever gravity is changing, use center of gravity. Whenever gravity is uniform, use center of mass. It works. So this is the formula for center of gravity. So can you do for this rod now? So the center of gravity ka formula is integral r df by integral df. Since the rod experiences different force at different points, the center of mass is not center of gravity. Let's see how will you do that. Where did I write that? So you already know F, na? That F is the gravitational force. So at a distance x, we're taking a small piece on this. So on this, the df, the gravitational force, centrifugal force is not real. Gm dm by x square. That would be x into Gm dm is m by r dx by x square by integral Gm m by r dx by x square. So this GMR will go off. This will go from r to 2r. This will go from r to 2r. Looks like you're getting ln, I guess. That will be dx by x. That will be ln 2 by 1 by 2r. 2 ln 2r. Yep. Clear with this? Clear with the center of gravity. Where is the center of mass of the rod? The center of mass of the rod is at x is equal to 3r by 2. That is at the center of the rod. Both are not same. So be careful with that. Center of gravity is different from center of mass. Take a 5-minute break. I will take the class till 8:15. I'll extend a bit, so I'll give you a less break also. Like we will write the exam from 8:45. Take a 5-minute break and come. People are already tired. Go get away from the screen. I'm giving you 5 minutes so that you can get away from the screen. Looking at the screen for 1 hour will put a strain. Come back in 5 minutes. Need to go to washroom or something. Go and come back in 5 minutes. The same thing on center of gravity. We have a solid sphere with a tunnel. In this tunnel, you kept a rope. A rope of linear density lambda. The length of the rope is r/2. So you're just hanging it. Now to keep it at rest, someone is applying force F. Find F for equilibrium and find the center of gravity of the rope. So the rope is hanging from the surface. Someone is holding it. So how much force should you apply to keep that rope at rest, and where is the center of gravity for that rope? E3 by lambda 8r. Okay, let's see that. Get the center of gravity in the meantime. I hope you remember. First of all, you need to know the field inside the thing. So what is the field inside? Field inside is minus gmx by r cube. And this is for x less than equal to r. Minus and indicates attraction. Same story. So when this rope is here, this was the center. Set a distance x from here. Because that x is the distance from the center, take a small piece. Dx. So the force will be integral gmx by r cube. That is your field into dm. dm is lambda into dx. Limits will go from r/2 to r. Solve this, you'll get the force. What about the center of gravity? So what is df here? df will be gmx by r cube into lambda dx. This is your df there. So center of gravity will be integral x df by integral df. Again, limits will go from r/2 to r and r/2 to r. Substitute there and solve. I will leave it to you. r/9 क्या? Because there is more force on the surface compared to this thing. So there. So you should just know about the center of gravity. Again, not something weird. Manageable. 7r/9. Okay, if you 7r/9. r/9 from the top क्या? एक बार चेक करो जैनिल वो कैलकुलेशन. Because R1N is wrong because there is no rope only there. I hope the calculations are clear, everyone. So there, the space elevator, center of gravity, tension. So there you can play around with those three things. We have an hexagon. There are 6 charges, plus Q, plus Q. They're in a plane. C is the center. Now it is observed. Now all charges are giving field lines. So if you look at this charge here, this field line which is coming out, it goes away something like this. Getting it? So the field line goes away something like this. So from the center, if you actually draw the line, so this field line was supposed to go in a straight line, but it got bent like this. This angle is your angle of deviation. Delta is the angle of deviation of the field line. Find delta. Now understand, this thing is giving field lines in multiple directions. Among that, I have chosen one field line which was supposed to go straight. Due to the other charges, whatever, it just became like this. So the field line got deviated. Find delta. Hope the picture was clear. All 6 are identical charges. Picture is not up to scale actually. I didn't draw it properly. Okay, it doesn't matter. You can figure it out. Picture is not up to scale. So नहीं report बचा. See, this is one field line, right? In reality, what you're saying, I'll tell you, see what happens. So this field line is there. This field line will go something like this. So at every point, right? So when I ask you what is the field line here, you won't say there are 2 field lines. You will take the resultant of these 2 and you'll draw a new field line. Na? So this is not the net field line ka diagrams. If you actually draw the total field lines, they would look something of this sort. That is all fine. I'm not interested in that. This field line would bend and become like this. So that line which is coming here, it feels it is going this way. Listen. So again, this is, should have an idea about it. Little symmetry there. First of all, it's all about little, theoretical arguments. Gauss law now, this is the problem with the chapter. Most of the chapter is just arguments because this is happening, because therefore it is like this, therefore it is like this, and then you try to figure it out. So from the center, if you look at this field line which is coming out, do you agree this will keep going in a straight line? That field line will go in a straight line. Why? Now see, now there is a symmetry, isn't it? Plus Q plus Q, plus Q plus Q, and this Q. So this plus Q is giving a lot of field lines. This field line will continue to go in a straight line because of symmetry, right? And this field line is going something like this. So as you go farther and farther, you're getting closer to this line. Now, if I go and stand here, now you will think every field line that is between these must pass through this region. Do you agree? All the field lines will pass through this region. And if you ask him, what is this flux? He will say, okay, this is 120 degrees. Now, when you look at this point charge Q, in that particular plane, I'm giving out field lines in all directions, right? You're giving out field lines in all directions. But this angle is 120. Therefore, flux in that region is 1/3 of the flux in the plane due to the Q charge, due to only the plus Q charge, which will be Q by 3 epsilon. Make sense? It's not even Q. I'll just simply say flux by 3. The flux in the plane by 3. Fair enough? Similarly, now we will use the same argument and we will say, forget about these field lines. If you ask this person who is at infinity, if you ask him, boss, can you see an hexagon? What will he say? He will say, I don't know what is an hexagon. He will say it is very far. So this guy will think there is a 6q charge at the center, because he will treat that whole hexagon like a point charge, right? At infinity, he feels there is a point charge of 6q. You won't see that hexagon. And if you take this angle to be theta, so from his argument, he will say, okay, the total flux must be, the flux again in this region will be theta by 2 pi into total flux will be 6q by epsilon. Or you can simply say 6 due to the point charges, so 6q by epsilon. Or 6 flux in the plane. Is that making sense? So we are looking this from two perspectives. If you look at all the 6 charges together, he will think this flux is theta by 2 pi. See, whatever is the flux in the plane, usme theta by 2 pi into 6 times the flux in the plane. The same guy, when he looks at only one charge, he will say all the lines are coming only from this plus q charge. That must be 1/3 of the q charge ka flux. But we know this field lines and this field lines are same. The field lines simply got bent, isn't it? See, if the remaining 5 charges are not there, what would have happened? The lines would have gone like this, agreed? Because of the 5 charges, what happened? The number of lines didn't change. They simply got bent. Kind of, getting it? So now, so this flux and that flux must be same. And this must be equal to the previous one. So flux plane by 3. So theta by 2 pi into 6 times the flux plane must be 1/3 of flux in the plane. This and this will cancel. You'll end up with theta is equal to pi by 9. That is 20 degrees. If that is 20 degrees, this is 60 degrees. This would be 80 degrees. Therefore, delta will be 100 degrees. Be careful, it's not 90. That will deviate by 100. So this question you have to do from two perspectives. You're just looking at the plus q charge, then you're looking at all 6 charges. And then you'll argue the flux must be same. Because the guy at the infinity does not know whether the lines are coming from a single charge or 6 charges. He should be seeing the same number of lines. Since the number of lines are same, the flux is same. Think about it. Getting it? No hurry. Think about that. You're still confused. Wednesday when we catch up after the class, we can still discuss. But any confusion right now, you can ask on this. Gauss law is like this only. The whole Gauss law thing, right? You have very less numericals. You have a lot of argument-based questions. Clear? Let's see. One more, someone. 80. Wait, I did a mistake here. 60, 20, 18 नहीं रहे, मैंने calculation mistake किया, ये 100 था. I was reading that as 100 and I said this is 60. Theta 20 na? 20, 60, 80, 100. Yeah. In the first scenario, what is happening? Akash, we'll discuss after the class. Stay back after the class. We'll discuss that.
Okay.
Then next thing. Hope you guys remember this thing. Xi cap to yj cap. This thing I taught you in mains also. I told you this. We will do it again. Find charge enclosed in a sphere of radius r. Whose center is origin. These deviated field lines are from plus q are still a byproduct of all 6 charges. Yeah, right, Vihan. Because when you actually draw the field line, so that, see, the plus q, right, when you're very close to that, the field is infinity here. So that field still belongs to plus q only. Isn't it?
Sir, but basically the field is of plus q, but it's like including all the effects. It won't be like we have to overlap the field of the other three to get something different.
No, see, when I said this field line, this is due to all field lines only, na?
Okay. But it's coming from
Agar it is coming from there.
Right. Thank you.
How to do this thing? Forgot. See, when you have a variable field like this, take a small region like a small cube, okay? Dx, dy, and dz. So this is what we'll assume. So on this surface, the field will be Ex. On this surface, the field will change by Ex plus Dex. So this flux due to the field on the x-axis. So Ex will cancel. You'll end up with, maybe I'll write it down for you, right? Ex plus Dex into what is the area? Dy dz minus Ex into area dy dz. So this will be Dex into dy dz. This is the flux only due to the horizontal field. So the flux through that small cube, you can do that, this will be Dex dy dz. Similarly, you can do the same argument with Ey, then that will be dEy. For Ey, the area will be dx dz. Same thing you can argue for dEz. That would be dy dx. There. This is the flux in this thing. Now, luckily here, the numbers are good. So here, what is Ex? So Ex is this guy. Ey is this guy. Ez is this guy. So that can be written as dex will be dx, dy, dz. Dey is 2 dy, dx, dz. This will be 3 dz, dx, dy. But I know dx, dy, dz is nothing but dv, the volume of that small cube. That would be 6 times dx, dy, dz. In this case, okay, not every case. Luckily, it worked out. This will be right for all cases. So remember this thing. This is a general formula. I can give you another weird function, and that would change. So this is the flux in the small cube. So which is 6 into dv. So for a small cube of volume dv, the flux is 6 dv. Now you want for a sphere. The flux will be 6 into 4 by 3 pi r cube. And this must be equal to charge enclosed by epsilon. That will give you charge q. Is that clear, everyone? That you should know. When I give you a field, how to get that. Same thing. I'll just change the numbers. Tell me what about this guy. Suppose if I give E is equal to 2 I cap plus 3y square minus 2 j cap. If I ask you find the charge density. How will you find that? Charge density is charge by unit volume. Find charge density. Find charge. I need more information actually. Find charge in a cube of side A whose center is the origin. Let's get that. Idea is the same. This is important, the thing in the red. So that you derived for everything. So DEX is that small change in field in the x direction. So same stuff. So we do flux in that small cube. And let's call it d phi. What is the formula? DEX, dy dz, DEY, dx dz. Dez is not there, so I'll not write. So this will be 2dx dy dz. This guy would be 3 times 2y dy dx dz. Now, when you integrate this flux, now I can take that as volume, or if you guys remember, there's something called triple integration. We can integrate dx, dy, dz separately because x, y, z are different. And the limits will go from minus a by 2 because it's a cube and the center is the origin. When you do the same thing for this guy, 3y dy minus a by 2 to a by 2, dx minus a by 2 to a by 2. So this is a triple integration because you are integrating for 3 variables there. So this y ka integral, right, this term will become 0. No? y square by 2, that a by 2, this thing will go off. So that is gone directly. So luckily, you'll get a pretty good answer. We'll get flux is equal to 2 into, that will be a cube. This is equal to q by epsilon. Therefore, q is equal to 2a cube epsilon. That's your charge. Clear with this? You want charge density, then it is q by a cube, so 2 epsilon. If you want charge density. Clear with the stuff? So this is how they can frame questions. They'll give you a field and they can ask you this. Similarly, you can, using this formula, if you noticed it, we got the flux. So this is the differential form of Gauss law. dy dz. So if I just multiply dx here and dx here, similarly dey, if I do dy, and then this is a dx dy dz. This is ez by ez. Again, I can do dx dy dz. That actually becomes a d phi is nothing but dq by epsilon, and this will become dv, and this becomes dex dey dz. dq by dv is nothing but rho by epsilon. This left hand side, right, it is written as del dot e bar. This is a differential form of Gauss law. That integral form is that integral e dot ds. So what is del bar? Del bar is nothing but dou by dou x I cap, dou by dou y j cap, plus dou by dou z k cap. It's a dot product. E bar will be ex I cap, ey j cap, and ez k cap. So when you do the dot product, you will end up with this, and this thing came from that only. Clear with this? So this is your differential form. This formula, right, integral E dot dA is equal to Q by epsilon. This is also Gauss law. This is called integral form. So just in case you see that delta symbol, don't get scared. So it's actually coming from here only. Clear with this? This is one type of models there. This is another good one. Hope you guys remember this. So we have a sphere here. Let's say this thing charges 2q. And the niche ka charge is minus q. It's a uniform solid sphere, but only the upper part is having plus q 2q charge and bottom part is having minus q charge. This is a uniform solid sphere, mass m and radius r, and this is rough. There is no slipping. And now what you did, you suddenly switched on an electric field E. You applied a constant electric field. Initially, the system was at rest. Find angular velocity. Find friction. Find angular acceleration. Friction on the ground. And omega, which is angular velocity, as function of theta. Theta is the angle rotated by the solid sphere. Meaning the picture will become like this. After some time, this will become the red color region. So this angle is theta. This is your minus line. Because of that plus charge on the top and the minus charge at the bottom, this thing will start rolling. It will try to rotate, and the friction on the ground will make it translate because it's not slipping. And I hope you know what kind of motion is this. This is periodic and oscillatory. It is not SHM. This is not SHM. Let's get this. Yeah, right, Aditya, get it. Why logic to why, yeah. If you remember in the class notes, I gave plus Q minus Q. I also had plans of messing up the mass also. Upper sphere is 2m and the bottom is m. That would have been more fun, but okay. Okay. Now, how do we do here? So the catch in the question is, again, we have to use center of mass. Tell me one thing. When you took a solid hemisphere and when there was a gravity there, so where did we write mg exactly here? In reality, if you see, every point has weight dmg, dmg, dmg. So the mass, the gravity is not acting at one single point, it is acting everywhere. But then we said, okay, I can just take the entire mg at the center of mass and the free body diagram and I can solve. So going from the same argument, now when you have an electric field E here, on every point you have a force E into dq, E into dq, E into dq. Now think about this thing in terms of mathematical perspective. Is there any difference between E and G and dm and dq? If you ask Max, Max will say, I don't see any difference. You are, instead of calling G, you're calling it E, you're calling dq as dm. So you just change the symbols. You're getting it? So if your charge distribution is uniform, you can replace the charge at the center of mass. This can be done only the charge distribution is uniform. If charge distribution is uniform and if you have a uniform electric field, same way, if your mass changing, the center of mass will change. So if your charge distribution is changing, we have to find an appropriate center of mass. But again, that's a lot of work. If charge distribution is uniform and electric field is also uniform, we can replace, the whole charge with a point charge at center of mass. People also call it center of charge, but yeah, there is nothing like that. There is no concept called center of charge. So just be careful. It sounds good. It's a whole charge with the point charge. You can use it, but remember, there's nothing like that. The point charge at COM. Perfect. Once you're done that, your life becomes easy suddenly. Now we have the solid sphere. Let's say after time t, when it has rotated by theta. So what is the center of mass for a solid hemisphere? Anyone remembers? 3r by 8. You should remember the results. So if you don't remember the results, you're gone. The exam, if you keep thinking, oh, what is the center of mass, then you're gone. If your field is uniform, then you can use center of gravity ka thing. So if you remember, this distance will be 3r by 8. And this force will be EQ, E into 2Q. Similarly, for this guy, the center of mass will be here, 3r by 8. This will be EQ because it's a minus Q charge. And this is a plus 2Q charge. Yeah, you're done. So, and the friction will be F forward. Since it is not slipping, you can take torque about any point. Yeah, you can take center of mass, or this angle is theta. So you can take about this point also. You can take about center of mass also. I'll take torque about A because I don't want to deal with friction because F ka value I don't know. So this will be E into 2Q. If both the charges are Q now, your life would have been easy. It would have formed a couple and you could have just done it directly, but now you can't. So the perpendicular distance from this thing will be this distance here, which is R plus 3R by 8 cos theta plus E into Q R minus 3R by 8 cos theta. That is equal to IA into alpha. What is IA? Parallax theorem, 7 by 5 mr square. It's a solid sphere. There you got alpha in terms of theta. Once you got alpha, you can do omega d omega by d theta. Integrate, you'll get omega as function of theta. You want to find friction? This is your acceleration. This is your alpha. F is equal to F plus E2Q minus EQ is equal to mass into acceleration. And acceleration is equal to R alpha since it is not slipping. Clear with this? So the main thing is once you replace that whole charge on the top at the center of mass, things will start becoming, it'll just fall in place. Then it becomes a rotational mechanics question. And you know what kind of motion this does? Oscillatory motion. So this thing will be like this. It will rotate like this and then it'll come back again. It will rotate forward, it will come back again. Meaning if you look into my screen now, this is how the motion goes. It goes front, comes back, goes front, comes back. Getting it? So it does almost, I think it does more than 180 degrees here because the 2Q charge is dominating, I guess. So you can check that out. Clear with this? Let's see one more. This is another good one. Let's get this. Read. It takes 2 minutes to read and understand what the hell is happening. So till now, when I'm telling you the question, I'm actually explaining you the question. So you guys didn't feel it. Fine, I'll get 3-4 minutes. Read, understand, try to get the thing. Question is understood. Did you guys understood the question? That is important. Before even starting to solve, first understand what is the question. Read. I'll give another 30-40 seconds, then I'll explain the question, then I'll give another 2-3 minutes to solve. First question should be clear. See the question. Two neutral particle like identical metal balls. So, okay, it's a metal ball. each of radius r, mass m, are connected by light inextensible conducting thread. So I don't know what is the question so far, but after reading these two lines, I understand this much. You have two metal balls and you connect it with a wire. That means no matter what you do, they'll have same potential. See, while reading the question, try to get the data points. You're getting it. Question kya hai? I normally have to read the question 2 to 3 times. But reading every time, try to get some data points. Okay, till here it is fine. Great. The balls are held in free space with separation between their centers L. Okay, this was L. And now everywhere uniform electric field is given. But what is capital L? Okay, L is the length of the rope. Small L is the distance between them. So now I'm trying to understand this inequality. So small L is this distance, capital L is this length of the rope, and what is smaller? Small r is the radius of the ball, and he's saying it is much, much smaller. Basically, he's telling you to treat these things as negligible radius compared to the length. So you can treat them as point particles. Perfect. And see, till now I still don't know what is the question. I'm just trying to gather data. Now everywhere a uniform electric field is directed, so E is uniform. Along the line joining the centers of the ball is switched on and the balls are released. Find the maximum speed of the balls in the subsequent motion. Okay. So if I read this question for the first time, I would be thinking like, okay, why are they moving? That would be my question actually, because you said neutral. Why the hell are these things moving? So that is where you have to start from. And then from there, I'll try to figure out. Take 2 minutes more. Think. Now, that is there. So that is the thing. You need to understand the question. That would, if this was an actual JE question, you'll easily eat away 2 minutes to understand what the hell is happening. And it'll take a minute to figure out why they're moving. I think it'll take another 2.5 minutes to, if you actually figure it out, it'll take around 6 minutes to solve. And this would not be a single choice question. This will be either a more than one choice or, yeah, could be anything. This is a tougher one. Not easy, but yeah, let's see. And anyway, advanced में कितना questions होता है? They might give around 18 to 22, depends. Even if they give around, let's say, 19 questions. And some questions, there will be easy questions. Why बोल रहा हूँ? They have to give easy questions because you don't have enough time for everything. There will be around 5 to 6 easy questions like standard models. जो भी notes अच्छे से किया, जो भी PYQ सब solve कर लिया, they can handle that 6-7 questions easily. They should get over in 3 minutes roughly each, 2.5, 3 minutes. And then you have to solve another 7 to 8 questions. In total, out of 19, if you can get 13, 14 right, you're in. Electric field metal को खींच लेगा. नहीं, why will it खींच लेगा, right? It will not खींच लेगा because think about it. There is no charge only. Force is E into Q. There is no Q only. नहीं. Electrons. But electrons are there on both the sides. Potential same, they have to be closer. There is a potential difference. Understand, when you have an electric field, suppose, imagine, initially there is no charge, so there is no force, but because of the electric field lines, potential will be V here it will be V minus dV, agreed? If they don't move, both will have this potential, but the moment you get a potential difference, will this wire keep quiet? The electrons will start moving. And this will become plus Q, and this will become minus Q. So iska potential hoga kq by small r plus V minus dV. Now this V minus dV is coming because of electric field. This must be equal to minus kq by r plus V. V and V will cancel. So the potential difference dV will be 2 kq by r. But potential difference is nothing but E into the distance between them. Are you getting this? The electric field between them will create a potential difference. But since you connected them with a wire, there will be charge flowing. Now you will get charges. Now because you got charges, right, the electric field will come and apply the force. And because of that, they start moving. I hope you got now why they're moving. Then क्या करना था? Because Akash, देखो ना, induced charge when you say, right, if you have a field, the induced charge will be how much? This side will come minus, this will come plus. It is still neutral, right? So that should not give you any force. It's still neutral. But the charges literally move from one to the other, so you'll get minus q plus q. And one more thing, did you notice something? If this is plus q, this is also minus q. Do you agree? They are equivalent opposite charges because total neutral tha. That means if this force is EQ, this force is EQ backward. What's the total force on the system? 0. So center of mass will not move. So these two will move in such a way, center of mass will always remain at rest. Matlab they will go in the opposite direction. String is trying to become tight. Now, if they move away from each other, won't the potential difference increase? And if the potential difference increases, won't the charge increase? That means the force is not constant. dV is the potential difference due to the electric field report. dV is the potential difference due to the electric field. I equated both the potentials. Na? See, it's a good one. So now what you guys can do, right? You take this as R and take this as 2R and then try to solve the problem at home. Bas question thoda change kar lena. And see what would change. So you might get something in that, you might not get anything, you might get an error also. Anyway, so first thing. So the 2 points are there. So this will be your center of mass. So for convenience, right, I can take this thing as x by 2, x by 2. So the distance between them is x. Let this be plus q. This will be minus q. Now the wire is still not tight, okay? The wire is still something like this. So that is your wire. So the force acting on this will be EQ. The force acting on this will be EQ. Since F net is 0, acceleration of center of mass is 0. Initially, center of mass is at rest. So here, center of mass will not move. Generally, center of mass can have a constant velocity. Be careful with that. 4-0, center of mass is not at rest. Center of mass will have constant velocity. Here, initially, nothing is moving. So center of mass also will not move. Great. Now, the potential on each one, this will be minus kq by small r, radius of the shell, plus the potential difference, let's call it a V1. This V1 is due to the electric field, and this will be V2 minus plus kq by r. So from here we will get V1 minus V2 will be 2kq by r. So this V1 minus V2 is the potential difference due to the electric field. Right, and that is nothing but E into x. There, I found the charge. E r by 2kx. So if you see the charge is increasing linearly, the more the distance between them, the more the charge on the shells. And then when will you get maximum speed? That is a question, right? You can clearly see now they'll keep on accelerating. So you'll get maximum speed when the string becomes suddenly tight. And once it suddenly becomes tight, you'll get a jerk kind of thing. And then, yeah, something will happen. We're not interested in that. So max speed occurs when the string becomes tight. Perfect. So what is the force on each one of them? E into Q. Since the length is much, much larger, actually, should I take the attractive force between them also? That will be K Q square by X square. That is the force between them is equal to mass into acceleration. This is the force on one shell. There is a force between them and there is a force due to the electric field. But what is Q? Q is again ERX. I think you can ignore that kq square by x square. I guess it is too small, but ठीक है, डाल के देखते हैं. E q is how much? Rx by 2k minus k q square. That would be e square r square x square by 2k by x square. Okay, luckily that got cancelled actually. That came out to be constant is equal to ma. You're done. You can ma is equal to v dv by dx. So you will get something into dx and you will get m into v dv. Limits will go from 0 to v max. This will go from x is the distance between them, right? Initial distance is L to capital L. But clear the steps. Yeah, it's a pretty good one. Won't the potential difference oppose electric field so as to Q increase the electric field? What are you talking, Ray? E is given constant and don't mess up things. It's a uniform electric field.
Yes, I'm assuming steady state means at each point.
Yeah, that E will be always same E only, meaning it will instantaneously, the charge will keep changing. So if you're asking about there will be a time taken to travel, don't worry about that. We are assuming that will happen instantaneously. Yeah. What did we achieve from center mass at rest? Nothing. We at least found, see, imagine if the whole thing was moving forward. Then it would have been a mess, right? Because if the whole thing is moving forward, then the electric field also will keep changing. We are not sure actually, meaning how is the motion going? So the center mass did nothing, but it just gave us an idea how the motion is happening. Both the things are going away from the center of mass. That's it. Okay, so take a break, right? Come back by 8:45. We'll start our test there. So have your dinner, finish it off. 8:45, come back and join on the same link. So we'll start the test. And you know the drill. I'll be sending you a PDF on the WhatsApp group. You can download it and you start the test. I'll be there monitoring you for an hour. So there'll be 25 more than one choice questions. You can't complete in 1 hour. That is the whole point. So your job is not to do all the questions. Your job is to select the easy ones and moderate ones and finish it off. And the remaining questions will be your homework. You can try them and I'll also provide you the solutions also. You can check them and finish it off. So that is a plan. So more than one choice questions is one thing where I want to focus more, because if you can handle that, you can handle most of it. Okay. Go take a break and come back. Anyone has any doubts, you can stay back and ask, or else go have your dinner and come back by 8:45 on the same link. So